Here we're looking at voter turnout in the last 5 elections, and the first thing we want to do is take a look at this data to see what kind of trends we notice. So here's the data already on our window. To get here, make sure your stat plot is on. Make sure that your data is entered and that your columns read L1 and L2. Press zoom 9 for zoom stat, and you should see the data there. So the first part also asks, what trends do we notice? Well, without writing anything down, we'll just say it looks like there's a quick drop and then an increase that's taking place at an increasing rate. And so that indicates one of a couple of things. Well, it sort of looks somewhat quadratic. So the first thing we'll do is we'll go ahead and fit a quadratic model to this. We'll go to Stat, over to Calc. We'll select option 5 for quadratic reg. And I want to also put a little trick to make sure that this equation that it's about to generate also goes into my y equals screen so that I don't have to type it in manually. So I'll go to vars, y vars, hit enter for function, and then select number 1 or y1. And what that will just go ahead and do is that will say we'll take the quad reg and then plug the equation into y1, but it'll also show it to us. So there it is. And now if you go over to y equals, you'll notice that it's also there in all its infinite glory. And we'll just go ahead and copy this down just to have a record of it. So we're calling this v of t for voter turnout as a function of time. And this is about 0.086 t squared, around about 3 decimal places, negative 1.116 t plus 54.117. Okay, so there's our equation. And of course this was in years since 1992. We don't want to enter years. We rarely ever do that. So we have 0, 4, 8, 12, and 16 for the years 1992 through 2008 because it's every 4 years. So 1993 is meaningless. And now what we'll go ahead and do is we'll go ahead and do a little interpretation. So we want to find L of 16. Excuse me, should read v of 16. These should be v's here. So v of 16, v of 16, v prime of 16. And v of 16, well, that's going to be the voter turnout in the year 2008. So this is the year 2008. And we want to know what is the model predicted voter turnout, which is not going to be quite 57.1 because it's going to be based on our model. We'll go to second table and we'll enter 16, and it's about 58.3% voter turnout. So that varies a little bit based on the actual number because this is a model and it's not 100% accurate. But we have to use it in conjunction with, if we're going to use the equation, we've got to use the equation solely. Now we want to find the rate of change in voter turnout. How quickly is voter turnout increasing or decreasing? So first of all, we need v prime of t. So we'll take 2 times 0.086 using our power rule. Gives us 0.172. And this is going to be t to the first power minus 1.116 t to the 0 power. So we get a linear function out of this. And now we're going to go ahead and evaluate this thing at 16. So that's 0.172 times 16 minus 1.116. And, oh, what's happening here? 0.116 times 16 minus 1. Oh, oops, entered a couple wrong keystrokes here. 0.172. Don't know what's happening. My calculator's freaking out. Minus 1.116. And that gives us 1.636. There it goes. 1.636. Now this is change in output over change in input. So our output from our original function was percentage turnout. And our input is year. So what does this say? This says that in 2008, voter turnout, I'll abbreviate that, was increasing by 1.636% per year. So not bad. Now percentage points, we don't actually mean that it's that many percent bit bigger. So we should probably say percentage points, because we're literally adding 1.63 to our old percentage. It's not multiplying it to figure out what's 1.636% of that. We're literally adding that to it. Now keep in mind this is per year, so over a 4-year period it would be 4 times this amount. However, because this is the derivative, we probably should not use it to estimate too far into the future. But anyway, this is a good sign. Voter turnout is increasing in 2008. Next, we want to find a cubic regression equation for voter turnout. So we look at the model and we say, gosh, looks like the quadratic does okay, but I kind of want to account for some more of this curvature, because it kind of looks like there could be some more curvature that we could point out here. So I'll go over to Stat, Calc. We'll do cubic reg now for cubic regression. And again, I want this to enter it into my y equals screen for me, so I'll go to vars, over to y vars, hit enter for function, hit enter for y1. Now it'll show me all the parameters, but it will also enter it into my y equals. And notice how great that r squared is. Now there's a sacrifice here. We made the model more complicated. We got a better fit, but the model is more complicated. So take a look at this, and now it seems to be a little bit more reasonable. And in fact, one might say, hey, the voter turnout increased a lot, but now it's not really increasing by that much. Maybe we're actually headed towards downward spiral again. So this is just a model difference, a little detail. So for the record, we'll go ahead and copy this sucker down. We have v of t is equal to negative, I'll go back to my home screen, negative 0.04015 t squared, t cubed, pardon me, plus 0.446 t squared, minus 3.176 t plus 55.267. Okay, so now we can evaluate, again we wanted to evaluate v of 11 in part F to compare, well, what's the estimate for the voter turnout in, 16 in 2008 according to this model. And so now all we need to do is go to second table. We already have 16 in there from the previous equation. So the voter turnout, 57.167%. And how does that compare to our previous answer from our other model? Well, in the other model we got 58.3. In 2008 it was actually 57.1. And look how close we are now with this cubic model, a lot closer. In part G we want to figure out, well, according to this model, what's the anticipated rate of voter turnout increase or decrease? So first of all, we need to find v prime of t before we can answer this question. So we've got to do power rule, 3 times 0.015, which is going to be negative 0.045 t squared, subtract 1 from the exponent. 2 times 0.446 is going to be, let's see, is that 0.892, I believe, t to the first power, minus 3.176 t to the 0 power, plus 0 for the constant. And now v prime of 16 just requires me to go ahead and, I'm not going to enter the whole equation in, I'll just go ahead and do it on my home screen. Negative 0.045 times 16 squared, oops, forgot a plus here, plus 0.892 times 16 minus 3.176 gives us negative 0.424. So, and this is again percentage turnout per year. This is just using a different model and different model assumptions. So according to this, voter turnout is actually projected to be on a downward trend in 2008. Now, part H asks us for, well, what do we believe is going to be best? Very hard to say. Again, it sort of depends on whether you really buy into this idea that the growth in voter turnout is getting to be slower and slower, so that must mean that eventually it's going to come back down. Or with the quadratic, you might argue that you expect it to continue to go up. Maybe it's these political times that would encourage us to believe that eventually we'll get 100% voter turnout. But that's a very subjective question.